Hello everyone, welcome to this video. I'm Amit RAHEJA, working as assistant professor in AISSMS IOIT College. Today we will learn about moment of a force. Before learning moment of a force, we'll see what is a force, what are the characteristics of a force. Force, it is an external agency which changes or tends to change the state of rest or uniform motion of a body upon which it acts. In the image below, you can observe the force can either be a push or it can be a pull force. When the force is applied on this object by the two uh, kids over here, you can observe either it can be a push force or it can be a pull force. Then what are the different types of forces? It can be a frictional force, gravitational force, applied force, drag force, spring force, magnetic force, tension force, and buoyant force. These are the different types of forces depending upon the nature of the forces. Frictional force, as the nature of the frictional force is to act in the opposite direction of the motion, so it is designated as frictional force. Gravitational force, it is due to the gravitational field of the earth and it is acting always in the downward direction. In the same way, different forces are there: applied force, drag force, spring force, magnetic force, tension force, and buoyant force. So these are the characteristics of a force. Force is a vector quantity. It can be it can be characterized by its magnitude, which is mentioned in Newton or kilonewton or maybe in kilograms. And second thing is the direction of the force in which the force is acting, point of application, and lastly nature or sense of the force. If effects of force, it may change the motion of a body, it may retard the motion of a body, it may retard the forces already acting on the body, thus bringing it into rest or in equilibrium. It may give rise to internal stresses in the body on which it acts. Next, these are the system of forces. Depending upon the point of application and the direction in which the forces are acting, we can classify the forces as coplanar forces, non-coplanar forces. Further, we can classify coplanar forces as concurrent forces, parallel forces, or general system of forces. In the image to my right, you can observe coplanar concurrent system of forces, then coplanar non-concurrent system of forces. That means all these forces, they are acting in the same plane, but if they are passing through one single point, then such a system of forces is called as coplanar concurrent system of forces. And if they are not passing through a single point, then we can classify them as coplanar non-concurrent system of forces. Further, the example shows collinear system of forces and coplanar non-collinear system of forces. Collinear system of forces, all the forces they are passing through a single point. Then we at the end we have coplanar parallel system of forces. In that you can classify the forces as like parallel and unlike parallel. The first image of the parallel forces is unlike parallel system of forces, and the second image in the bottom right is the parallel system of forces, that is like parallel. And the image in the left of this in the top left of the screen is the non-coplanar system of forces, also called as space forces. Then we'll come to understand what is moment of a force. So the rotational effect of a force is known as moment of a force. In the image given below, you can observe a wrench is used about a nut to release it or to fix it. We apply force on the edge of this wrench or on the handle, and it is applied in the downward direction. Due to this, a rotational effect is produced at the nut. So this point at which the rotational effect is produced is called as moment center. Now you can observe the force is acting in the downward direction and the distance at which it is acting from the wrench is it's acting at a perpendicular distance. So moment, basically it is a rotational effect of a force, and we can compute its magnitude by multiplying the force into the perpendicular distance from where it is acting. So moment center and the force, the perpendicular distance between them is used for finding out the magnitude of the moment, that is force multiplied by the perpendicular distance. This distance is measured from the line of action of the force till the moment center. That this distance can also be called as lever arm. Okay, so this is moment of a force. Now we'll see an example on moment of a force. In the diagram, we can observe different set of forces are acting, and it's an unlike parallel coplanar system of forces. So we need to compute the moment of all these forces about the point P. So moment of this 6 Newton force about point P is obtained by multiplying 6 into the perpendicular distance, that is 2. Now as we can observe, already the forces are acting at perpendicular distances to the moment center. So simply we need to multiply 6 into 2, and this moment is going to act in the anti-clockwise direction. Then next, 14 Newton force, the moment about point P is 14 multiplied by 2, that is 28 Newton meter in the clockwise direction, as 14 Newton is acting ahead of point P at a distance of 2 meters. So we will multiply 14 into 2, that is the perpendicular distance, and we'll get 28 Newton meter clockwise moment. Lastly, 5 Newton force is acting at a distance of 5 meters from the point P. So 2 multiplied by 2 plus 3, it is 5, and we get a 25 Newton meter anti-clockwise movement. Now by taking the summation of the clockwise and the anti-clockwise movement, we get 9 Newton meter in the anti-clockwise sense. So the final moment that is acting about point P due to all these forces is 9 Newton meter in the